Hello everyone, and welcome to this example recording on equivalent resistance circuits, specifically Y-delta transformations. So in this example, we're requested to determine the equivalent resistance from point A to point B, which is going to be the resistance looking into the circuit. Right, so first step is to always identify any series and parallel circuits. Right, we've got elements, and we can see that there aren't really any series or parallel connections as yet, mainly because of, if you look at this section of the circuit, because of this 10 ohm resistor, we can't say that the 30 and the 60 or the 40 and the 50 are connected in series or in parallel. Right, but what we can see is that you've got a point of connection between the 30 and the 60 and a single point of connection between the 30 and 10 and the 10 and 60. So we have a delta connection here, and likewise we've got a delta connection here. So we could convert the delta connection to a Y connection to then have a circuit resulting as follows. Right, and that circuit will then join the rest of the circuit. And once we do that, then we will be able to see that, well, the resulting circuit here will be in series, the resulting resistance will be in series, that will be in series, the result of those two would be in parallel with each other, and then the whole circuit will be in series. So let's determine these resistances. Right, so we are moving from a delta to a Y configuration. Let's see what those equations say. If we want a delta to Y configuration, then we know that we're looking for resistances R1, R2, and R3. So resistor R1 would be RB/RC over RA/RB/RC. What does that mean? Resistor R1 is the adjacent resistors multiplied over the sum of all the resistances. So if we go back to our circuit, if we are looking for, let's call this RA, or rather R1, R2, and R3. So if we look for R1, we know that R1 will give us the adjacent resistors multiplied, so that will be 30 times 60 over the summation, which will be 30 plus 60 plus 10. And R2 will be the adjacent, which is 10 times 30 over 30 plus 60 plus 10. And R3 will give us the adjacent, which is 60 times 10 over 30 plus 60 plus 10. Right, and if we do this calculation, the first one will be 30 times 60 over 30 plus 60 plus 10. That gives us 18. The second is 10 times 30. That gives us 3 ohms. And the last one is 60 times 10. And that gives us 6 ohms. Right, so we have an 18 ohm resistor. We have R2 a 3 ohm resistor. And we have R3 as a 6 ohm resistor. So now we should be able to see that the 3 ohm and the 40 ohm are in series, which will give us a 43 ohm resistor. The 6 ohm and the 50 ohm are also in series, which will give us a 56 ohm resistor. And you've got your 80 ohm resistor. Right, and you have your 18 ohm resistor in series with your 20 ohm resistor. Right, and we should be able to see then that RAB must give us 20 plus 18 plus 43 in parallel with 56 plus 80. Right, 43 in parallel with 56 will give us a value of 24.32, and then if we add this to 20 and 18 and 80, that gives us a final value of 142.32 ohms. And this will be the final resistance with respect to terminals AB. So it's important to note that we could have gone either direction. So we could have also converted this delta into a Y, and then we do the series parallel connections and we simplify the circuit. Thank you for watching this video and enjoy the course.